In my first video on this channel, I showed you how to use the blocker type introduced in CastEffect 1.4. Today, I will show you how not to use it because it doesn't exist in CastEffect 3 and we have other things to use if we have to deal with blocking. So let's get to it. We're going to look at the changes in how we do blocking nowadays and migrate our example from the first video to the new way of doing things. But first, let's recall what blocking is. Every time that on the JVM a thread has to wait for some resource that is only accessible by one thread at a time and some other thread is using it, then that thread has to go into a blocked state. Such things can be disk access, maybe some sort of lock between threads, maybe you're calling system processes, or if you're using a blocking HTTP client, a blocking HTTP call. One example of a library that is doing a lot of blocking is JDBC, which is the standard library interface for talking to databases on the JVM. And because threads on the JVM are quite expensive and heavyweight, we cannot create thousands or millions of them. We cannot run every HTTP request that gets sent to our server with a single thread, because eventually we'll just run out of threads and we won't be able to take any more requests. So we need to separate out these blocking tasks and let whatever is running our application that this part of the program is blocking and this part isn't. And the tool that allowed us to do this in CastEffect 1 and 2 was Blocker. And now it's gone. I'm going to show you the replacement. So let's look at our example. In our example, we had a JDBC trait which had a single method execute, and that method was implemented in terms of blocker. So given a blocker, we would run a blocking task on it, namely printing a message to standard output and blocking the thread for 1 second. This blocker would be given to us in the constructor of the JDBC instance, which would be passed from the outside. We would get a blocker by calling the blocker.apply method, blocker apply of IO. This gives us a resource of IO and blocker. This blocker wasn't tied to any specific effect, just the resource was tied to IO because we used IO when creating it. We would map on that resource to get another resource and change, like from blocker, we would go to a JDBC of IO. So the result would be a resource of IO, JDBC IO, and we would take that resource and use it with the execute method. So this is how we dealt with simple blocking, just taking blocker delay. This was a syntax for something else we could do, block on, and then we would wrap the block in sync of delay. This is actually not possible in CastEffect 3 anymore. We cannot just take an arbitrary task and say that this has to be blocking. We can only pass like a closure, a blocking piece of code that has to just be suspended on a blocking thread. So this is the JDBC part. Also note that we had the context shift constraint here. We needed that to be able to do blocker delay. I'm going to show you another example with FS2, a very common popular library in the type level ecosystem. It also used the blocker type. That was a very, very typical use case that, for example, when reading files, we would use the read all method in the FS2IO file package. We would supply the path to the file and a blocker and the chunk size, the buffer size, how many bytes we want to read at a time. And here we still need the context shift instance and we still need the blocker. And this was the source of a lot of confusion and a lot of kind of boilerplate code, because you would need to basically take this blocker and pass it around to all the functions that would need it. And it's something that many people said it should be built into IO itself. And as a matter of fact, now it is. So let's upgrade to CastEffect 3 and FS2 3. So I know that these are the latest versions. Let's update the build. Okay, so the build was updated and we should be able to compile this, except we can't because many things that we are using no longer exist. So context shift doesn't exist anymore. We can actually just remove it. Blocker doesn't exist anymore. I'm also going to just remove it. And the same goes for this. So JDBC resource IO, we no longer need this resource, but just to minimize the changes, I'm going to keep it. So I'm going to remove this blocker part and I'm going to put this into a resource pure. Now I'll remove this blocker parameter again. And here we need to do something about this call. So blocker delay is no longer an option, But since we have the sync constraint, we can say sync f blocking, and that's it. Now this fs2 example, let's also fix that before I explain what happened. We're also not going to take a blocker. We're not going to take a context shift instance. We're just going to use the API here. And as it turns out, this method is deprecated. The better way to do things now is files.io read all. Let's talk about this. So we are using files of IO. This is returning a files of IO instance. So if I wanted to do this in tagless final style, previously I would need sync, I would need context shift, I would need the blocker, right? So now all I need here is actually files, and I can change my IO to F, and this just works. I can optimize my imports. All I need is files and Java paths, and this is it. So not only is Casifex 3 more friendly to blocking, you also get fewer type classes to carry around. Of course, this one is from FS2, but even if we had just sync, okay, maybe not sync, we could just have async. Still, it's one type class that we need to carry around, not two type classes and a blocker. So yeah, the Casifex 3 ecosystem has moved to this direction. And let's get back to our blocker demo. So here I'm using sync of f.blocking, but if this was written directly with IO, I can implement maybe this right next to it in IO. So this would be JDBC of IO. And I can say IO.blocking and do the same thing. And the important part here is that blocking is available directly on IO, and it has no implicit parameters, or no parameters at all, just this action that we want to run in a blocking way. So there are no implicits here, and you can actually, you don't need to import the whole of Casifex. Just here we have this sync constraint, we have this IO app, we have resource, but ultimately, if all you want to do is this instance, all you need is IO, so you don't need any more imports. So I think this is also a really cool thing about Casifex 3, because you get to use IO directly without bringing in a lot of stuff that you don't care about. All you'd have to do is use IO. So let's restore all this code. And yeah, we have this exit code, I think. Yeah, all the things are in Casifex, the Casifex package. Now I'm going to show you just one more thing. First, let's get rid of this resource. We no longer need it because blocking is built into IO. So we don't need this use, we can just do execute. And there's a new thing. It is backported to Casifex 2, but it first appeared in Casifex 3. We can use IOApp.Simple, and now all we need to do in our run method is return unit, IO of unit. And it will do the exact same thing in the implementation. It will just use the success code if your application succeeds. So what most people just did anyway. All right, so what happened here is that blocking is now available in IO, and we don't need to pass a blocker or any blocking execution context to it. But to execute an IO, we actually need something like that. So if we were to call unsynchronous sync, we would need something called an IORuntime, and in IOApp we obviously don't need to do this because it will just take an IO from us and it will use a runtime internally. We do have a runtime here. We have access to the runtime in IOApp, but we don't need it anyway. And a runtime contains a compute pool, so something like a CPU-bound execution pool, a thread pool for running CPU-bound actions. It has a blocking pool just for blocking actions. So basically, what we would have in Blocker is now part of the runtime, the execution contexts used to run our IOs. Then there's a scheduler to run scheduled actions like sleep and getting the current time, and that's basically it. That's what we can find in IORuntime. But the most important part is that to run an IO, you need this, but you don't need to carry around blocking pools to do blocking actions in your IO. All you have to do is provide a runtime at the end, the so-called end of the world, which is actually IO.app. There's one more change that was related to blocking in Casifect 3. We can access it both through the sync type class and IO directly. It's called interruptible. So if we say, let's start with false, I'm going to explain this later. Now, if you run this blocking action and it takes a lot of time to execute, and you want to make this interruptible so that you can maybe start it and eventually cancel this task, then you can just do it. If you use interruptible, your blocking task will still be interruptible. The runtime will try to cancel it once. If you specify this flag, it's called many. If you say true here, then the runtime will just try to interrupt this task for as long as it takes. So it will just repeatedly try to interrupt the thread that takes care of executing this block. And this is new in Casifect 3. Some people wanted this, so it's been added. But if you don't care about interrupting, if your tasks aren't supposed to run forever or for long periods of time, and you just want to do some sort of blocking, you can use IO.blocking, and in many cases it will be enough. But if you really need to interrupt these tasks, try interruptible and see if you need the flag or not. So this is it for this video. I encourage you to check the migration guide, which describes this in more detail, and link in the description. And if you liked this video, let me know what you thought. Leave a thumbs up, subscribe, and hit the bell icon. And I hope to see you in the next episode. Thanks.